you needed for 5-5 day one. So I will just cover questions on 5-5 tomorrow, depending on how far we get. And we're still working on our objectives here. Really the big one is going to be the ambiguous case that we're looking at. And then we're going to start talking about some word problems. And the really important piece about the word problems is going to be making a correct drawing. Once you have the correct drawing, the rest of it's going to go pretty easily. Yeah. Oh, the older stuff. Yeah, So we're still trying to finish up all of our objectives here, understanding and using the law of sines. Basically, as long as we know we have angle, angle, side, or angle, side, angle, two angles and the side of the triangle, we can use the law of sines. And then side to side angle, if we set it up correctly, then yes, we can use that if we take a peek at it and see we have what we need. And then we're going to apply that law of sines to the real world applications. So we got stuck by the clock. Not too far into this, if I remember right. Yeah, this one right here. So what we had done is we had taken care of the situation that most people see right away, which is, yes, I can get a triangle here. This would be a big, nice triangle, and everything's good. But the clock caught us when we went to our little sliver triangle over here. And what I had demonstrated yesterday was, by doing the first one and not storing my numbers, that's going to be a mistake. And that's because what happens is I can make a rounding error when I go to do my other triangle. So we were over here, and we had already found the measure of angle B for that side. And our measure for angle B over there was 35.685. The problem is that's not an answer for something in our sliver triangle. It's a really important piece of information, but it's not something that's going to give us our new angles A, B, and C, which I really wish they would have done like primes on there or something. But just know that we're talking about a different triangle that's been formed here, even different letters would have been nice. So if I know that that's 35.685, it's helpful. It's just not something that's in this triangle that I'm looking for. So what I have to realize is this was 6 originally. So when it swung over to form this other triangle, it's still 6, which makes this an isosceles triangle. And if it's isosceles, the isosceles triangle theorem tells us that when two sides of a triangle are the same, then the angles opposite them will also be the same. So this angle is also 35.685 degrees. Still not an angle in our triangle, but with some very easy math, we can now figure out what the measure of angle B is, because this is a straight line. And every straight line is 180 degrees. So if we know this one is 35.685 right here, well, we'll just subtract from 180 and we'll be able to get that one. So I realize if I didn't store it, I've got a chance here that I might have a rounding error. So we're going to cheat and put that one back in and store it. And I've already got it punched in up there. So from yesterday's math, we needed the inverse sine, and you'll see it on your paper where we did this before, of 7 sine 30 degrees divided by 6. And it wasn't perfectly 35.685. We had some numbers after that we needed. So I went ahead and redid that one, and I stored it. Wouldn't necessarily have to store it now once you got it in there. You should get it. So you could always punch it in again, but that's a little extra time that maybe you wouldn't want to spend on something like that on the test. So just getting used to storing these is going to help you out a lot. So I've got that, and now I need to do 180 minus that answer. So 180 minus, and second recall, alpha x, pops it right up into place, and there it is. So 144.315. So the measure of our new angle B is 144.315 degrees. So look at the triangle and think, okay, I've got angle A, angle B. That's 144.315. And just thinking ahead, pretty obviously I can find angle C now by taking 180 degrees and getting what I need. I just want to think, which one of those am I going to need later on? You know, maybe I should store everything. Maybe I don't have to store everything. Well, really, the only other piece of information I'm going to need is this lowercase c here for this opposite side. So once I find C, I really don't have to store it if the next thing I do is use it for this. So as I said yesterday, it's never a bad plan to just store things and keep track of them all the way through. Then you'll know that you have it, but with a little planning beforehand, you'll know which ones you need for further math. So now we have this set up with the measure of angle B, and we just need the measure of angle C. Every triangle has 180 degrees. We're going to subtract the 30 degrees that they already gave us, and then we're going to subtract our 144.315 degrees, which is still stored in my calculator up there. Technically, I didn't store it in for a variable, but it's still in there. It's in the memory of the calculator. So I take 180 minus 30, which is 150, and I subtract the answer that I just had. So 5.685. Now I don't clear it because I realized I'm going to need that if I want to find that opposite side C. So I go back and think the nice easy one, the one they gave me, the one I want to use is the 30 degrees with the 6 opposites. So sine of 30 degrees over 6. And if I need lowercase c, well then it's that angle C that I'm going to need. Sine of 5.685 degrees over lowercase c. We do the algebra beforehand, and then we can just use the answer key to get that 5.685 plus the other decimals in there. So we cross multiply. C sine of 30 degrees equals 6 sine of 5.685 degrees. Divide both sides by the sine of 30. C pretty quick. So parentheses 6 sine of my answer, and divide that by the sine of 30. And there it is, a little 1.18. We're going to have to go with 9, so 1.189. And we have it. This process is going to work every time that we have this ambiguous case for the side-side angle. And that's because to get that second sliver of a triangle, we still have to swing that side over. It's going to force an isosceles triangle on us every time. So we just have to think about where these angles are. Now, they don't give us the picture of this. We have to draw the picture. And that's going to be the key. If we can get our picture drawn accurately so that we can see all of the angles that we need, then we'll be okay. So this is a little step in the right direction, but now let's do one from start to finish here with no picture. So we have solve triangle ABC. All right, so we know what the triangle is going to be labeled. If A is 43.1 degrees, and I start thinking about how we need to set all these up, that just told me I want my A angle over here. Lowercase a opposite that. And then we talked about how the placement of the other side length always has to be adjacent to the angle that they gave us. For us to know, we can use the techniques that we were using before spring break to figure out how many triangles. Now, we can pretty much guess this is going to be 2 triangles, but we're not supposed to guess. We're supposed to know. So one of the first things we would do is figure out what the height of this triangle is, just to make sure that 186.2 is going to meet the bottom. And that would be by dropping down an altitude. Altitude is the fancy name for the height of the triangle. and just using sine to figure out what it would be. So the sine of 43.1 degrees equals h over 248.6. And that'll give us 248.6 sine of 43.1 degrees for h. It doesn't take too long to punch that in just to make sure that we're going to get two triangles here. And 169.862 for rounding. So 186.2, definitely longer than the height. So we're going to get at least one triangle. Now how we tell if there's two is we say to ourselves, okay, now if I swung this over, is that going to be shorter than this side? So it's going to hit again. It is. This one is going to be two triangles. So we're going to have that two triangle situation. So probably should redraw this. I'm going to use primes. I just can't stand that they're calling everything exactly the same. And we put a capital B across here and a C here and a C here. But I'm going to call this A prime, B prime, and C prime. In the end, we can label it the way they have it, that B and C. But I want to make sure everybody knows we have two different triangles that we're going to be looking at here. So with this one, we have our little sliver, like so. But we're still going to have the 43.1 degrees. We're still going to have the 186.2 over here for little a, and 248.6 over here for b. But now it's set up so we can see how everything's going to come together. So let's start doing some math. We can basically ignore the h. All of that was to figure out whether or not we're going to get two triangles or not, and we know we do. So where is our set of opposites that we're going to want to use every time we look at this stuff? A and A. So sine of 43.1 degrees over 186.2. This lowercase b that's opposite that. So sine of b over 248.6. Cross multiply. Divide by that 186.2. What are we going to do to that so we can figure out the measure? Yeah, we have to do that inverse sine. Probably going to need that again. So we've got 65.819. Good. I'll think ahead again. I know I'm going to need that when I go to my second triangle. So not a bad idea to just go ahead and store it right now. So store, and then I'll just use x again, so alpha x, and enter. But as I said before, X with a circle helps you remember. That's where I have this one. So now we've got the measure of angle A and the measure of angle B. What should we do next? Let's go after C, huh? Since I'm talking angles. So the measure of angle C is going to be 180 minus, well, they gave us 43.1 for A. And there's 65.819 that we had for B. And let's see how that works out. So 180 minus 43.1 minus, and now I can either do second answer because that was the last thing that I typed in, or I can recall it as X. So 71.081 degrees. We have everything? All three angles, all three sides? What's left? Okay, so let's think ahead. Do we want to store that? Is that something we're going to need later on, or can we get away with just using this? Let's store it then, just in case. So, store, and I'll put this one into Y. So, alpha 1. Never hurts. I mean, maybe you don't need it later on, but if you do, it's going to save you a little time. All right, so let's go back to the original. We had A, sine of 43.1 degrees over. We had lowercase a, that was our 186.2. And we now know that angle C is our 71.081 degrees. And we need lowercase c. So cross multiply again. Getting to the point where you want to skip the step where you have to divide too. Yeah, I am too, but we're not supposed to do that. You know, we're supposed to show every little step as we go through this. So C equals 186.2 sine of 71.081 degrees over the sine of 43.1 degrees. That one we had stored. Wouldn't have to really, because we've got it sitting right up there as our answer. So 186.2 sine, and we'll go ahead and recall it. So second, store alpha y, pops it right up in there, and we need that divided by the sine of 43.1 degrees. 257.790. Should we store that? That's the side length. We store it? No, the other triangle doesn't have the same side length, does it? So you could store it. It wouldn't hurt anything, but you don't need, we're not going to need a side length. That's the angles that we need to keep really close tabs on. So did we get everything? Okay, and just to save time, I'm not going to do that inventory, which I would certainly do with normal. Go through all of them. Yeah.
On the last triangle, though,
because the side length we keep is one they already gave us. That's the side length that stays. That was our lowercase b. Same thing's going to happen here. This 186.2 becomes 186.2 over here. Right, because this one is 248.6. It's this little side that's going to change, and that little side is that lowercase. So that's not going to be the same. Alrighty, well, we found B, right? And we stored it. We need that because we need to know what this was. So our measure of angle B, where did we do that down here? That was our 65.819, which we stored in X. That's important because that means this angle is also 65.819. Now, that's going to help me figure out. I should put my B prime up here so we can see that. How do we get that B prime angle then? Yes, 180 minus our 65.819, which we stored so we can get that exact. So 180, that one I stored under X. 80 minus, recall, alpha X, and enter. 114.181. Where's the X? Measure of angle C? Yep, we need that one. So we want to store B. Okay. Are we going to need that to find lowercase c? No. So that wouldn't hurt. I mean, if you want to put that in for z, it doesn't hurt, but we're not going to need it in the future. So the measure of angle C, we need to do 180 minus the 43.1 minus the 114.181 degrees, which is already in our calculator right now. So technically that one does not need to be stored. 180 minus 43.1 minus the answer that we just had. 22.719. Now, it's up to you whether or not you want to store that one, but really it's sitting there ready for the next math that we have to do. So you wouldn't have to store it, because what we're going to look for now is that lowercase c. So we go back to the original and realize it's still going to be sine of 43.1 over 186.2. It's just that our 186.2 is right here. The sine of our 22.719 degrees over little c. So we will have c sine of 43.1 degrees equals 186.2 sine of 22.719 degrees. And then we will divide. Punch it in. So on the top, 186.2 sine of the answer that we have up there, so second answer. And I'm going to divide that by the sine of 43.1. 105.247. Degree label on that one? Nope, that's a sine. So again, I just, with the stuff we have left today, I can't take the time to do the inventory, but I would normally stop and say, okay, here's the measure of angle A, measure of angle B, measure of angle C, A, B, and C, so you know you have all of those found. So hopefully, that went a little bit better there. So that's the ambiguous case. That was probably the biggest part of our objective. Now, the rest of these, they're word problems, but they're not going to take as long as we have a good picture. And a lot of times they give us the picture, but sometimes the hard part of it is getting the picture. After that, things will go really easy. So this is the other part of our objective, which is really the word problem piece. Forest Ranger Chris Johnson at Ranger Station A, so here we are over here at A, sights a fire in a direction 32 degrees east of north. Oh, right there. Cool. Got it all labeled for us. Ranger Rick Thorpe at Ranger Station B, right here, 10 miles due east of A, so due east, 10 miles, sights the same fire on a line 48 degrees west of north. That makes sense. West of north is going to go there. Question. Find the distance from each ranger station to the fire. So what we are supposed to find are those two right there. Well, I don't know any of the angles inside my triangle. Can we find some pretty easily? Okay, so if this is due north and this is due east, how many degrees are we talking about? That's 90 degrees. So if this is 32, what would this have to be? Something. Break was way too long. 90 minus 32. 38. Like I said, break was a little too long. All right, and then over here, same situation. So a 58 and a 42, and that makes sure that we have two angles. And if we have the two angles, then we can use the law of sines. So we'd have two of them that we have to find. And do we know any of the sides that are going to be helpful? But I don't have the angle across from that. So how do I get it? Subtract from 180. What is it? So now we just need two of these. So we'll have the sine of 80 degrees over 10. And might as well do it in alphabetical order. We can go after A first. The sine of 58 degrees over 8. And then the next one will be the sine of 80 degrees over 10 equals the sine of 42 degrees over B. So here's what we're going to do to save a little time, because this is pretty basic after what we just did. I want these three rows to figure out what lowercase a is. Just do the first one. And then I'll get back to you and talk to each other so you make sure you have the right answer. And then these three rows, you go after lowercase b. Go after that side. Again, talk to each other. Make sure you've got everything right. Thank you. Doing that. Losing myself in the math. We're checking in with each other here. All right, you ready for me? Still punching? Other? Okay, Hannah, since you're right in front here, why don't you give me what you got for a little A? 8.611, and this time we had a label, miles. Well, it's easy to forget because for so many of these you don't get labels. We get back to word problems and finally we have it. Lainey, what'd you get for B? 6.79. Me too. There we go. So this goes a lot faster, even though it's a word problem, because it gave us a nice picture. So if we can get that picture, then we've got finding the height of a pole, and this one's a little different, and that's because the ground is not perfectly flat. So we've got a road that slopes 10 degrees above the horizontal. So I know it looks flat because it's a two-dimensional drawing, but they're saying there's this 10-degree slope that's happening here. And it says we've got a vertical telephone pole that stands beside the road. So here's the pole right here. The angle of elevation to the sun, 62 degrees. The pole casts a 14.5-foot shadow downhill along the road. Well, that's going to go right here. So that's our C value right there. Find the height of the telephone pole. Okay. Well, we did a little geometry here. We could say there's a new transversal here, and these would be corresponding angles, so this should be 62. It's not because the road slopes. So it was supposed to be 62, but 10 degrees of that slope is going to be eaten up by the road. So this is now going to be 52 degrees right here. And where the pole was meeting the ground, does everybody agree it's supposed to be 90 degrees? Isn't that what's supposed to happen when you put a pole in vertically? But it's not going to be because it's sloping down from the pole. So what's it going to be now? It's going to be 100. And I can't fit all this in here, so I'm going to put 100 degrees right there. Because it's going to do 90 degrees and slope another 10. So see how this one gets 10 taken away because of the slope? While this one gets 10 added to it because the slope is going down from the pole. Naturally, what would we do first for the map? Find the other angle, yeah. Find the measure of angle C out there. So 180 minus 100 minus 52, which you probably just said, I'll just subtract 152 to get that. So what's the measure of our other angle up there? 28 degrees? Okay. So what were we supposed to find? The height of the telephone pole. So was the 28 useful? We need that, don't we? Because we need a set of opposites to set this up. So with our 28 degrees, I have to blow this triangle up a little bit for future use. 28 degrees is opposite that 14.5. We need that. And now, what should we use for the one we need? Yeah, because we've got 52 opposite the angle. All right, so go to it. Yes, I'm skipping this up. Because I'm going to make up for a little last time with that through those both triangle problems. Chicken wing and elk part. Let's make sure we've got the right stuff here before I ask it away. Not saying it's right, that's just what I eavesdropped and heard. 24.338 feet? Yeah. Yeah. That's the right one. So again, I'm skipping a step here just because we've got to get rolling, we've got two more. And what do you notice about example 6 and example 7 that might make them a little harder? No picture. So we, bless you, are going to want to be very careful about the picture. Pretty obviously, if we have the picture, this was a piece of cake. We have to get the picture. A satellite orbiting the Earth passes directly overhead at observation stations in Town A and Town B, 340 miles apart. Okay, so Town A, Town B, and they're 340 miles apart, passes directly overhead. Well, maybe they'll give us some more information about exactly where that is. At an instant when the satellite is between the two stations. Okay, well, I'm just going to put it up here then. Call it C. Somewhere between the two stations. Its angle of elevation is simultaneously observed to be 60 degrees at town A. Elevation, is that looking up or looking down? That's up. Cool, that's inside our triangle. I like that. Simultaneously, 60 degrees at town A and 75 degrees at town B. Looking up at the satellite. There we go. How far is the satellite from town A? Well, we better put our little A's and B's in the right place. And from town B. But we're going to have to label that a little bit better when we get to the end. It should be good. Find C? All right, so let's do that. We've got 60 and 75. Together, that's 135. So how much do we have left for our angle that we need? Ooh, 45 degrees. Now, normally, I'd be really excited about that because I'd be like, oh gosh, we can give this exact. You know, we can do an exact, but we don't want exact. This is a word problem. We want decimals anyway, so it's no big deal. So now that we know that this is 45, are we good to go and use the law of sines? Okay, so sine of 45 over 340 equals the sine of 60 degrees over little a. Let's do the same thing again. Let's have these three rows find A and these three rows find B, and then we'll all come back together here. Somebody. A little slip of the finger and you have the wrong answer. See a bunch of you are doing both of them instead of just doing one here. That's okay because you've got to write it in your notes, so if that happens. Looks done. I know it's done again, but I already had one. Sam, did you get A already? What'd you get? Give me the decimal again. I got 416.412. Okay. Yeah, you got it on the calculator. It's just getting it on the page there. And what was this in miles? Yeah. Okay, and then B. Josh, you're looking ready. What'd you get for B? 164.449. Yeah, 464.449 miles. I already forgot the last decimals there. 49 miles. Now, because this was kind of worded weirdly, we were supposed to tell them how far is the satellite from town A. That's actually B. So we would probably want to put town A right here. And town B. So that it's labeled according to what the question asks us. So, again, you've got the picture, then you're good. You know, the picture is the big deal. And the picture is really a big deal on example 7. We've got a lot going on. To measure the height of a mountain, okay? Measure the height of a mountain. A surveyor takes two sightings of the peak at a distance 3,000 feet apart at the same elevation. Okay, so that means they're at the same height, but they're 3,000 feet apart. So here's the height. They could have been here and here, 3,000 feet apart. That would make sense. They're at that same elevation, but they're 3,000 feet apart in there. The first observation results in an angle of 48 degrees, and the second results in an angle of 35 degrees. Which is first and which is second? So let's see. We're standing at one of those spots where they're doing this, and we look up at the mountain. When I move back, does the angle get bigger or smaller? It's smaller. So the bigger one has to go here. All right. If the transity used to measure the angles is 5 feet tall, let's just make this even more complicated. So the transit thing is actually 5 feet tall down here from the base. We're going to have to remember that when we figure out the height, because they want the height of the mountain. All right. Well, that doesn't change the math that we're going to do to find this, which I'm just going to label X, because it's not really the height of the mountain. We have to add 5 onto that. Okay, so let's see. How can we get that? Well, we already have these two lined up across each other. We have this information. If we could figure out this one, wouldn't that give us a pair here that we could use, sine of 90 degrees over that? Okay, so how do we get this one right there? What's a piece of information we would need in our sliver triangle here that would give us that? Yep, if we can get whatever this little angle is up here, then we're good, and we'll have it. So, how are we going to do that? Can we figure out what the angles are in the sliver triangle? How? You guys are saying yes. How do you get it? Oh, straight line right here. Good thinking. So 180 minus 48. What are we going to get? 132 degrees. All right, let me see if I can put that in there. So we had to find that in order to find what? Angle way up there at the top. You don't know the entire side. No. See, and that there's another way to do this one, but the algebra is really intense. It is really intense. So this is the easier way to go after this one. Did you already get the little sliver angle up there? What'd you get? How much? 13 degrees. But does that make sense? It does. It makes sense. This is supposed to be a little sliver. Okay. We set to figure out why. Alrighty. So we've got our opposites here. We've got 13 and 3,000. What do we have to use on the other one? The 35. So sine of 35 over our y. So go ahead and find y. here's what I need you to ask somebody that's sitting next to you, shipping in over part. Shoot that to school. One way or another, we need to keep track of that number, right? If we do it right, it's quite possible we might be able to just do second answer and use that for the next math. But it never hurts to say, oh yeah, I'm going to need that to do the other math I have here. So let me figure out how to store that. All right, so we're close. We now know that this 7649, I'm just going to put blah, 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 so I'm not trying to put that whole thing in there. Now do we have enough to use lob signs in the other triangle? Okay. So we need sine of 90 degrees, kind of interesting, we haven't been able to do that before, over 7649.350 equals sine of 48 degrees over x. But again, we will want to have stored that 7649.350. Okay, well, that we will finish up tomorrow. Rats, we're so close. So we will just come back and you know what? Finish that one up on your own and we'll come back and check the answer because you've got that number stored in there and I don't want you to forget where you stored it and we'll have to retype everything in again. So we'll just check in with each other and make sure that you've got the height of the mountain, but you add that additional 5 for the transit, okay?